Let's take a look at probability topics today. Chapter 3, we're going to start with terminology. Probability is a measure that is associated with how certain we are of outcomes of a particular experiment or activity. An experiment is a planned operation carried out under controlled conditions. If the result is not predetermined, then the experiment is said to be a chance experiment. Flipping one fair coin twice is an example of a chance experiment. A result of an experiment is called an outcome. The sample space S of an experiment is the set of all possible outcomes. There are three ways that we represent a sample space. They are to list the possible outcomes, to create a tree diagram, or to create a Venn diagram. It's important you understand what a tree and Venn diagrams are, but we are not going to work very much with them in this course. The uppercase letter S is used to denote the sample space. So an example is if you flip one fair coin, then the sample space equals heads or tails, where H is heads, T is tails, and those are the outcomes. Let's take a look at an example. If you flip one fair coin, where H is heads and T is tails are the outcomes, we can represent the sample space in three ways. So you can list the outcomes. You can say sample space equals the outcomes of heads or tails. You can create a tree diagram that looks like this. The ends of the branches gives the outcomes in the sample space. Or you can create a Venn diagram. An event is any combination of outcomes. Uppercase letters like A and B represent events. For example, if the experiment is to flip one fair coin, event A might be getting at most one head. The probability of an event is written P parentheses A close parentheses. So we would say probability of A. The probability of any outcome is the long-term relative frequency of that outcome. Probabilities are between 0 and 1 inclusive, and that means that it's 0, 1, and then all the numbers in between those values. So if the probability of A is 0, that means the event can never happen. If it's 1, it will always happen. And if it's 0.5, it means that the event A is equally likely to occur or not occur. So for example, if you flip one fair coin repeatedly, from 20 to 2,000 to 20,000 times, the relative frequency of heads approaches 0.5. That's the probability of heads. Equally likely means that each outcome of an experiment occurs with equal probability. For example, if you toss a fair six-sided die, each face, 1, 2, 3, 4, 5, or 6, is as likely to occur as any other face. If you toss a fair coin, a head and a tail are equally likely to occur. And if you randomly guess the answer to a true-false question on an exam, you are equally likely to select the correct answer or the incorrect answer. To calculate probability of an event A when all outcomes in the sample space are equally likely, what you do is you count the number of outcomes for event A and divide by the total of outcomes in the sample space. So if you toss a fair dime and a fair nickel, the sample space is heads, heads, tails, heads, heads, tails, or tails, tails. The sample space has 4 outcomes. So A is getting 1 head, and there are 2 outcomes that meet this condition. If A equals heads, tails, or tails, heads. So since the outcomes, there are 4 outcomes that are equally likely, we have 2 over 4, or 0.5, as our answer. If we look at another example, 3, you roll one fair six-sided die with the numbers 1, 2, 3, 4, 5, 6 on its faces. Let event E equal rolling a number that is at least 5. What's the probability of the event occurring? So there are 2 outcomes in this event E. 5, and 6. So those are at least 5. If you were to roll the die only a few times, you wouldn't be surprised if your observed results did not match the probability. But if you were to roll the die a very large number of times, you would expect that overall 2/6 of the rolls would result in an outcome of at least 5. You would not expect exactly 2/6. The long-term relative frequency of obtaining this result would approach the theoretical probability of 2/6 as the number of repetitions grow larger and larger. Here's another example. So it says, use the following information. A jar of 150 jelly beans contains 22 red, 38 yellow, 20 green, 28 purple, 26 blue, and the rest orange. So let B equal the event of getting a blue jelly bean. So the probability of blue. All you have to do is look at how many blues there are, there's 26 blues, over the total number, which is 150 jelly beans. And we do this for each of these problems that you can see here. It's the same procedure repeated over and over again.